Very good. Today is Wednesday, February 22nd, 2023. Welcome everybody to SIG API Machinery bi-weekly meeting for open source Kubernetes. My name is Federico Bongiovanni. We are having the bi-weekly meeting today, and I see some interesting items in the agenda. Thank you for all of you to help us populate it. I think we have Joe on the call, so let's begin with Joe right away.
Thanks, Fede. So this came up when we were talking about some limitations that we had with validating admission policies, which is the cell way of doing admission control. One problem that we have is that we don't have very fine-grained versioning of resources, and what it makes it really hard to run cell compilation on types. I don't know if I'm introducing this very well, but kind of the problem is like when you think about a built-in Kubernetes resource, you have the group version kind, and the version is usually v1 for most types at this point, and but they do change at a cadence, right? So like in 126, 127, you can add new fields in a backwards compatible way. That's not really part of the GVK version, but a lot of people think of that as being like a minor version in semantic versioning speak of that type. So some people might even like if you ask them like which version are you talking about, they might say the Kubernetes version and tell you which version of the built-in they're talking about. Let's try and be more clear. And
yeah, I think people have referred to this concept as like micro versions in the past. Like Tim Hawken has been a large fan of tracking them in some way. Anyway, please keep going.
Yeah, I'm glad to have a name for that. And then in CRDs, the situation is even more dire because it's kind of the Wild West in for terms of versioning. Like you can say you have a version, you can pick V1 or you can pick V1 beta 1 or whatever you want, and then you can just change the scheme in any way you want. And there's really no way to know if what you actually have, right? And if you're a third-party developer and you're at V1 and you want to introduce some new fields in a backwards compatible way, it's even harder to say what micro version you're at, because how would you do that? There's no support at all for it. It's just completely missing.
Can I add something? I think people may not understand why you're saying this.
Okay.
Is this about the it's hard to write a cell rule that is valid and checks the potentially new field and stays valid across an upgrade or a downgrade? Is that why you're
yeah. So
okay.
Sorry, let me back up. So when you write cell, you're writing like little expressions that can access objects, and you're supposed to know what the fields are. And cell is, despite being like an embedded language, it's actually a type safe language. And if you tell it the schema of something, you can do a type check across it, and it will tell you everything you would need to know. And that allows you to do really useful things, right? Like you can write a cell expression and know that, like if you're doing development and you change the name of a field somewhere, and then you're supposed to also go change the name of the field in your cell expression, type safety helps you remember to do that, which is a really practical thing, right? And it moves a lot of classes of errors back into development time and out of runtime, just like you would expect. And when we did CRD validation rules, in a CRD, you can go and add a cell rule saying like, validate this CRD, like validate that this field, does something. We get full type safety there because we have the exact schema of the CRD in the same YAML as our cell rule. So we're pairing that cell rule with an exact schema of something. And so it's very clear like what we should type check against. But then when we switched over to doing admission control, now we have one resource that contains a cell expression and other resources that are in separate definitions, either in YAML or OpenAPI or whatever, that can change independently from that. And we want to get a lot of type safety there, and we've been pushing to try and find ways to do it. And we're kind of coming up against the wall because we can't talk about versions of things very well.
So are you specifically interested in this for the cell aspect of it, or do you see this as it would be really nice if we had the ability in the QAPI server to give warnings when somebody creates an incompatible type change, right? And so that would be two different applications, I think, right? When one is a given old and given new, is this legal to do? And another is, please name this.
I mean, it's been an itch for a while, and this was kind of like a really major reason to care, maybe even more than I had in the past. Like, it's always bugged me a little bit that like you can't know which version of a CRD people have. Like that you can't like the third-party developer has this CRD and like they've been making updates to it. If they've been doing that in a backwards compatible way, that still is different, and they can't really talk about that. It's just kind of weird. So it does bother me that there's no like backwards compatibility checking automation, that there's no naming system, and that kind of whole class of things. I think we do a really good job these days, although mostly by hand. We do a really good job for built-in types on keeping them backwards compatible. Actually, it's not that manual. We do have some pretty good test suites that are like fuzz-based that make sure that we do that. But CRDs have no tooling, and it would be really nice if in the API we could even talk about versions. Like you could say, this cell rule expects a pod that is 117 or newer, and it's written for that, and it's not going to work for something older. And then you just wouldn't be able to put that policy into a cluster where it's just not going to work. You would just be rejected rather than having it break weirdly at runtime.
So I think the difficulty with that approach is that you need these policies to work over upgrade events, and at some point the definition of the pod is going to change. And so like either you have like a set of policies that works on the old version and a set that works on the new version, and API server automatically disables the one that doesn't match, or within the policy you've got like a cell rule that differ, like you instead of one cell rule you've got like an array that differs based on version. I don't know if there's other options. And if you're going to do the thing where you've got potentially multiple versions of the cell rule, and the API server uses the one that matches the version of the type, instead of having API server name the type, which although I would like to do, I think it's probably not feasible in any sort of reasonable time frame. Imagine you had a cell expression that selected the version, right? So if you know that like there's the new field, you could have a cell expression that checks whether the field is valid or not. You could even just have it mention the field, and API server determines if it type checks or not, right? And if it type checks, then it does the one cell rule, and if it doesn't, it does the other cell rule. Maybe that's a way out of this conundrum.
Yeah, that's an interesting idea. Yeah, I don't actually have full-on solutions yet, and so that's kind of one of the things I was hoping to hear is, had people thought about this before? I do like the idea of even just being able to inspect the version would go a really long way with built-in types. I had naively been thinking a little bit this like when you depend on a version of something in a language module system, right? Like you're usually okay with it. Like most module systems will be like, oh, you said you needed 117, so you can work with 117 or newer. And so when I do conflict resolution, I just not able to.
Yeah, the problem with that approach is just over upgrades and downgrades.
Yeah, that's a really good point. The downgrades are pretty scary.
We've got some hands. I think David is first.
Mike, actually.
Oh, okay.
Okay, so yeah, so let me make sure I have some solution comments, and then first I want to make sure I understand the problem. For built-in types, we have, as you say, API group and API version. For CRD, do we not have API version?
We do, but there's nothing to force it to make sense, and it's very coarse-grained. Like so. You basically have two to pick from: V1, Beta 1, or V1. I mean, I guess you could use Alpha 1 too, but you kind of have three, and then once you get to V1, you're kind of like That's it.
The problem is people don't change the version when they add a field that's backwards compatible.
That's true
Yeah,
for built-in types as well. So actually,
Right.
the real issue is if you're making, well, there's two kinds of changes, right? There's the change that changes the version, and there's the backward compatible change that doesn't change the version.
Correct.
And so I'm trying to, in the problem part of this question or my remarks, trying to understand what's the real difference from built-in types. Is it simply we don't trust developers to have the same kind of discipline because we're not providing tooling that they run in their CI that checks as well? Or is there some difference?
Yeah, I think the problem is the opposite of that. We have to trust developers to get it right.
Well, but the point is, yes, we can't enforce it, so we don't believe it. We don't want to have to trust the developers. Is that really the problem?
The problem is the problem is more like even assuming the developers are doing the right thing and they're following all the rules that we follow in the built-ins. You can't make a cell expression. You can't easily make a cell expression which is valid if it cares about a field that's going to be added or has been added. You can't make a cell expression that's valid for both versions of the type.
I see. Right. It may not type check. All right. So now let me move on to my solution comments. First, yes, because of rolling upgrades, we have no choice. We have to make code that runs in an API server when there's a mixture of objects. During a rolling upgrade, there are both old and new objects. So we need, admission control that works with a mixed population of objects.
Any one API server should only see one kind of object, but the cell expression is evaluated from multiple API servers, so it sees both kinds of objects.
All right, fair enough. Now for solutions, remember that changes can include removing fields as well as adding them. So automatically detecting the version based on what gets referenced, I think is not going to work in general. I do think, you will need some sort of a collection of rules, of version specific rules. And, in Cell, you have the option of not type checking something, right? So you can write a non-type checked discrimination policy that tells you which type check rule to use.
We can do that. And that's actually what we're doing today in admission. We mark certain types as being dynamic or not type checked, and then you just don't get type checking.
But that's not what I was saying. What I was saying is a two-phase thing, is have a non-type check thing that only picks out of the array of checks that you really want to do, right? The question is, how do you detect the version? Okay, you can write some non-type check cell that detects the version. And then once you know the version, then you run the type check code that is specific to that version.
I think that's very similar to what I was saying.
Yeah, that seems like it would help a lot. With built-in types, I can actually imagine that coming together pretty quick, because like you could kind of during cell evaluation, you could know which version you have. And so we just have to figure out how to express that.
So these versions, you didn't explicitly indicate it at the beginning, and then I think you sort of backed your way into it. Getting the sense that you want to have a way to represent essentially a semantic version on the micro version of an API, as opposed to just there is a difference. Is that a restriction of what you want to create here?
I think we want to. I don't know if it should be exactly like. I don't know what the micro version exactly should look like, but I have a sense that we want something simple where we can say, like, if it's this version, and the easiest one for me to imagine is like, if it's 1.27, then I know certain fields exist and I'll run this logic.
Yeah, I'm actually thinking I'm actually thinking it's better to just test for the presence of those fields directly, rather than like testing for the version and somehow knowing that the version means those fields are present or not. Right? If you test for the fields directly, you can't be wrong. But if you check the version, like, you could be confused or have read the documentation wrong or something.
Wait a minute. Optional fields could be omitted, right? So that could be confusion.
No, but we're testing against the schema, not the object, right? We're testing about the object's type.
Okay.
So testing to see if a field is present also gives you the advantage for cases when maybe you have a tech preview version of CRD, or it is certainly possible today for someone to create an alpha schema for a V1 of a CRD to add a new field conditionally. It does similar logic to what we do. And I think you want to properly handle those cases. I think we also have to, I guess I don't know exactly when this compilation is done, but something is valid when the expression is created. And then, so for instance, I create this new cell expression, and then later I change the schema in a way that makes that cell expression invalid. And I think I'm not clear on when you're doing this version check.
The version check needs to be done both when we're applying the rule and when you admit the rule, right? So like ideally, if we go to execute the rule and discover that it no longer type checks, you should get a status condition or something.
Okay, and that seems like it could be done against I'll say relatively live schema.
Yeah, it should be against a live schema. Yeah,
you should have a live one. Does this start looking like you basically duplicate the subset of the schema that you care about into the object where you're defining the cell rule? You basically like just use OpenAPI to say, here's the sub schema I care about, and as long as it matches what I'm given, then I know I have it.
I wouldn't duplicate the schema. I would just have a cell expression that references the field or fields of interest, and if that cell expression itself type checks, like you can decide which cell expression to use based on a prior one and which one of those type checks.
Only if nobody ever deletes fields.
No, it has to work. It has to work both directions, right? Right, like the case where you're doing something because a field isn't present is the false branch of whether a thing referencing the field type checks or not, right? Because removing a field is the same as going backwards in time across a field addition, right? So it has both.
I agree with the time travel, but my point is saying that this expression applies if it only references defined fields is not consistent.
Yeah, it has to be like, if it type checks, do this. If it doesn't type check, do this, right? It has to be something like that.
No, that's what I'm saying. That's not enough, because supposing when you delete a field, you're making a semantic change to the remaining fields. So the expression that type checks without the field is going to succeed in type checking both when the field is present and when it's absent. And if its meaning is wrong when the field is present,
no, I'm saying you have a cell expression which references the field, and if that type checks, the field is there. If that fails to type check, the field is not there.
Yeah, it'd be a cell expression you never evaluate. You only type check it.
Yeah.
Okay, with ordering on, maybe that'll work.
Yeah. Yeah, I'm sure we can work. We can work it out. Something.
Yeah.
It's or just a
partial order. So it could still.
Or you can have a cell expression and a Boolean. Like, do you want this thing to type check or do you want it to not type check? Okay, we've got some other things on the agenda.
Yeah, thank you all for your time.
Work this out offline.
Okay, next one is Austin. Do we have Austin on the call?
Yeah, can you hear me?
Yes.
Cool. Yeah, I hope this is a quick one. So I was just trying to get some feedback on this PR to allow non-global metrics providers for the WorkCube package. It seems to have stalled with feedback that there's already a global factory, so you can actually kind of hack around the global factory to get per queue metrics providers. I put in 2 GIFs about where that's kind of not flexible enough for what I'm after, which is integrating work queue with OpenTelemetry, where you want to add like really specific bits of context to your meters. So really the queue metrics factory right now just gives you a name. So if you wanted to add more context to the meters that you have for the queue, you would have to encode it into the name, which is really inflexible. So I guess my last comment here was not understanding where global providers are better. And if we could just, I think this last bit, if we could just say, hey, this global set provider method is deprecated if we have the ability to set per queue providers. Does that make sense to people?
I tried to skim this just before the call, and the discussion with Alvaro was a set of questions I also shared. Like I'm not clear on how this will help in a case where you want to have a different overall metrics provider and you still lack a way, I think, to do that.
Why? If you have the ability to set the provider to be used at queue creation time, isn't that
because when it's
what you could do?
The library that you're using is still going to have it specified to be whatever it is, right?
Yeah, I'm wondering if you could open up this global queue provider and this per queue provider, because I guess there's something I'm not understanding here. Like with the current approach, right, you create a provider and then you set this provider, and then whenever you create a new queue, like you give it a name, and then that's what gets passed into the provider. If you want to get more granular than that in this per queue one.
And so I'm using library code that has the line work queue new named. And and that library has set that value to whatever it's going to be for that library forever. I don't understand how adding a new argument that you won't be able to change in the library code will let you change the metrics provider that you want.
So it's that static thing. That's actually that's not quite true. That it's the same forever, right? If you have the ability to add a different provider per queue, like it's like I'm creating queues dynamically, right? If I want to add bits of context into this provider, like say I've got like an org that I want to attach in a project, like dynamic labels, right? And kind of customize the meter in there. I can do that on a per queue basis, it's not a library code thing. Not like
can I ask where that information goes in the metric besides the name?
It goes in like the label. So in OpenTelemetry, there are attributes, right? So you can add bits of, like, say I'm creating a work queue to handle requests from Google. I'll create a meter that has the kind of granular details about this queue, which is for Google, and add that to the meter as an attribute.
How is that different from defining all the labels that could possibly be used, and like the work queues that have those attributes have them and the ones that don't?
Because there's no way to kind of do that dynamically, right? The only way you can do that kind of, even if you had the ability to define the entire set of labels, like you would still have to encode that into the name, because that's the only bit of context that the factory methods are given. Right?
Would your problem also be solved if you could pass different labels in?
Yeah,
instead of
I mean, yeah, sure, but I think labels are a pretty Prometheus specific implementation detail.
yeah, I'm just trying to understand the problem. I'm
but
not
yeah.
suggesting a solution.
Oh yeah. Yeah, so the problem is the factory, right, is all the context that's given is a name, a string name.
Does it work to change the package global before constructing each work queue?
No, there's a set once.
I see.
Clever, but I just don't understand why global. Like, it seems like there was some support on the issue for not having a global. I just don't understand why global is good.
I haven't read this issue, and so I don't know if I would argue that global is amazing or anything, just that I'm having a hard time understanding why you would have different labels for different work queue. Like, I thought the work queue internally used labels and registered several different metrics. So
yeah, so I guess this is different from Prometheus in that Prometheus, you have usually a static set of labels, but like there are more and more backends coming out that can support kind of like arbitrary cardinality in your labels. And one of the things that OpenTelemetry allows you to do is kind of get really granular details into your metrics.
Can you give an example of like a label that might be dynamic like this? Because I don't know if I'm definitely not following.
Mm-hmm.
Maybe other people are.
Like the organization name, right? Like that could be dynamic, right? Or
but you would, I mean, wouldn't this metric also have to differ along the name?
The name could be the same, but
you would use the same name for many different work queues and distinguish between them by selecting on labels, is what you're saying.
Exactly. I mean, that's how like a Prometheus system works, where like the set of labels is the identifier for the actual time series.
Yeah. Okay.
I mean, I don't want to.
I don't think I can say anything live because I haven't considered this.
I do have one other question based on the back and forth with Alvaro. I'm guessing this came from controller runtime. And what I'm wondering is the controller runtime library calling set provider? And if you were able to set your provider yourself, would that resolve your issue if you don't actually want to change the provider that other people are using or that other callers are using? You only want to change the provider for your queues, I guess.
Yeah, so I am using, so it is coming from controller runtime, but in an application where we have controller runtime and also use the work queue outside of controller runtime. So
could the fix simply be we go tell controller runtime calling set provider is limiting this use case? In order to avoid this, perhaps controller runtime should not call set provider and instead make it optional. Would that also resolve your issue?
It's sounding to me like there needs to be some way to pass either a set of labels or a provider per work queue, and then you build the labels into the provider. Right? Is that basically what you're asking for?
Exactly. It's kind of two different things, right? There is this kind of detaching it from the global, but also just making it flexible enough to add arbitrary context. So these are very similar questions to what Alvaro wrote. I don't want to take up too much time on this call.
Let's follow up offline. Why don't you ping me on Slack if I don't say something on the issue soon?
Okay. Okay, will do. Thanks, Daniel.
Thanks. Okay, I think I have the next agenda item. Fede, can you let me share my screen?
Yes, I will stop sharing. Sharing.
Yeah, make sure I get the right one. Yeah, okay.
Yes, we see your screen. Seems to be the right one.
You are on mute.
You're muted, Danny. Yes.
Yeah.
It happened when he started presenting. This happens to John Bell Merrick all the time.
Okay.
Zoom does not.
Does that work?
Yes.
Yeah. Okay. There's a button to like share my to like take the audio from the slide deck, which is weird because I don't have any audio on the slide deck. Yeah. So I have been thinking for a while about a number of issues in Kubernetes, or things that I perceive as issues, and I think there's a way to solve a number of problems at the same time. So I have here a slide deck which first is going to go through all of the problems that I see are related, and then sketch out a design for solving those. So and if you think of problems in the same theme, let me know. But I've got like 12 slides on problems, so maybe I've already thought of it. Okay, so and this is the first time I've gone through this deck, so forgive me if I forget what my slides are. Okay, so the basic theme of this is feature flags, and so some of these problems are about those. Some of these problems are about related things, and I don't know if I've got them in a sensible order, but category of problems is users don't have access to Kube API server command line flags in typical installations. This means there's like, even if the platform wanted users to be able to select which features were on or off, there's no way to do that without building something custom, right? And yeah, managed clouds, not even cluster admins can change features on and off. The problem with this, like ordinarily I wouldn't care, but the problem with this is combined with our long version life cycles in Kubernetes, it makes it really hard to get feedback from end users. You add a feature to Kubernetes, it's 3 releases before it gets to GA, and it's a release or 2 more before it's universal and clusters everywhere. And like that's like a year and a half before you get feedback before it's easy for people to give you feedback, right? So I see that as a big problem. Another problem, once you've turned a feature on, you can't really turn it off again. You can turn it off again, and what that usually means is stop accepting new uses of the feature, but it definitely doesn't mean like go through etcd and remove instances of the feature, right? So if you turn on a feature and it causes a problem and you turn it back off again, you may, instead of fixing the problem, put your cluster into a third state, right? The state where you know, depending on what is wrong, like maybe there's bugs where you can't even delete the feature again because it doesn't pass the update logic because the feature's off, right? So so I think our current implementation of feature flags is very risky. Kind of extending the prior 2 slides, there's basically no way to test an alpha feature on a production cluster, right? Because you turn it on, if it destabilizes the cluster, you can't really turn it off again, right? The only way you can realistically use an alpha feature is on a cluster that you don't care about, and that makes it hard to like use it in a way that is going to be meaningful. And that's, you know, it's partly that's by design. We don't want to make it too easy to use alpha features, but I think it should be possible to get meaningful user feedback while a feature is alpha and still very easy to change. This is more of an operational issue. You can set the different binaries in the cluster inconsistently, right? So you can turn on a feature in API server and forget to turn it on in controller manager. or you can have a feature on an API server and on in kubelet, but kubelet is 2 versions old and that feature means something a little bit different, or maybe they're incompatible because it's an alpha feature, right? Maybe it's alpha in kubelet and it's beta in API server. So this is a way to get yourself in trouble, especially if you're manually setting these flags. Okay, now more developer focused. When it would be handy if when somebody turned on my feature, I could do something to the cluster, like, I don't know, add a field to the schema, or when I turn my feature off, scan through etcd of the relevant objects and take that usage out so that I can put my cluster back into the original state, right? But none of that is remotely plausible, right? We don't store like whether features were on or off across restarts, which is the only way to change them right now, right? So there's just no way to do any of that. It's unreasonable to ask people to do this. This is a specialization. A common complaint, or one that we've had for years at this point, is that there's no place in the code to install a CRD when somebody turns a feature on, or just when you start up the cluster and a CRD needs to be there somehow because something important depends on it. There's no bootstrapping location to actually do the CRD installation. So if we solve the prior problem, we would solve this problem also, right? Because we could add a feature that tracks a particular CRD, right? And it could be on by default, and when it transitions, that gets installed. Related problem. Our API documentation just contains all the fields that could plausibly be on, or that could be on, whether plausible or not, and the automatic like the documents, this open API spec, etc., those don't change depending on whether the feature's on or off. So if you turn if the feature isn't on, you still see it in the documentation and in the schema. That's something we could change if we had a place to run code. So this is where I start to connect some other details. We don't have any programmatic knowledge of feature states, like unless you have command line access to API server, or well, all the binaries really. You don't know what's on and what's off, and even if you have that, you don't know what's been used, which is the more critical distinction. And not knowing what's been used and what's not used makes it more difficult to know whether it's safe or not to upgrade API server or the cluster, right? It's also like today you can only know this in general if you've read the release notes in detail. So I'm kind of hinting at a world where we, like, all the manual steps and whatnot that are in release notes, we build those into a feature, and we notice the transition of the feature, and code executes those manual steps rather than requiring humans to do it. Right, so I basically want to make it really safe to do upgrades and downgrades. A further problem with our feature flags, I told you there were a lot, is that we don't really test them properly, right? Partly because it's so hard to turn them on and off. So, like in my ideal world, we require a feature provider to give us a snippet of code, or a snippet of code that exercises the feature, and then we can have one, instead of having a separate E2E run for every feature, we can have one or a couple E2E runs where we turn on all the features, use them all, turn them off again, and then run the E2E tests. Right. So this is about verifying that when you turn the feature on and use it and turn it off again, the cluster goes back to a usable state. Right. This is calling back a few slides to where I don't want you to end up in a weird third state when you turn it on and off again. I think I meant to remove the slide actually. The complaint here is that you turn a feature flag on and everything about your cluster is affected at the same time, right? There's no canarying. I'm not sure how to add canarying into it, but it's certainly not possible today. One thing that I think is possible, if you've got like a feature that affects all the kubelets or whatever, I think we can report back whether it's used, right? So maybe it's not safe to use it in control plane until all the kubelets have observed that it's on. That is achievable. Okay, so overall, the benefits of fixing, if we could like fix these problems, we can make features safe to try in real clusters. We can codify upgrade and downgrade safety checks. And okay, David, do you want to interject now?
I'm gonna ask when you plan on taking comments. We've covered a lot of ground, and everyone was super polite waiting.
I think I've gotten through the problem, so yeah, go for it.
Okay. I guess I'm also willing to go first, but I will happily let anyone else raise their hand as well. Go back another slide. And oh, sorry, one more. That was the one you said it was an accident. This here, combined with the slide before it that was talking about programmatic knowledge of feature states, sounds a lot to me like the old operator pitch from CoreOS, where the idea is you're going to have a piece of software that manages the orchestration of how you turn on and off features or flags or any capability in that cluster across all the different binaries that need to have it happen. I think many of us know from experience that's actually significant to build and often relies on the vendor-specific deployment strategies to actually roll out and actuate these changes across kubelets, across CSI drivers, across controller manager and scheduler and the API server, and then back pressure into systems that control upgrades and downgrades is also a significant part of it. Is this proposal trying to tackle all that? And if not, how would it try to enforce rollout of CSI driver features? We have this release about what is it, read write once pods that requires, or read write once volumes that requires coordination across, I think, every one of those pieces. So I'm just trying to get a sense of this question is like, what is the scope you're looking at?
Are these the like CSI drivers, do they use Kubernetes libraries? Do they use our what is it, the controller library that defines the features?
Some do and some don't, but like, let's even say we accept that CSI drivers handle this somehow. How would you orchestrate this across just all the kubelets, and the scheduler and the controller manager and the API server?
Yeah.
Like, are you trying to get the scope that big, or are you trying to get smaller?
Okay, so yeah, the client library. So there's a client that replaces the command line, the command line feature gate, and the client reads the state of the features from the server and reports back to the server whether it's using a particular feature or not. And to solve the problem where like there's 1,000 kubelets in the system and they all want to report back that they're using something, instead of everybody reporting what they're doing, everybody looks at their own configuration and looks at the object in the server. And if that object in the server says that this configuration exists somewhere, there's no need to update it, right? So only one client has to update it, as long as that's representative a number of clients, you don't have to update it. So basically from the server's perspective, you don't get the progress bar that I was hoping for, but you get a like, is somebody in this particular state or not? And you know that you can't, so you know there's a transition, like if you try to turn something on, it goes in, it doesn't turn it on right away. It goes into a transitional, like I'm turning it on state, and it observes the reports back from all the clients. And
Okay.
as long as somebody's saying like, hey, I'm here and I have it off, right? You know, you haven't exited the transitional state yet.
So scope wise, this is trying to solve the same problem, and it's trying to solve it instead of handling the how do you actually roll out and manage different binaries. It's trying to say, I own these binaries and I will make it that these features turn off and on every binary live, and they report status back.
So I've actually got two. There's two models, right? Like if you happen to build, like if the feature is stateless and it's like, I don't know, something that's checked on every request or something like that, then it's actually no problem to turn it on and off live. But I think most of our features are not like that. And my theory there is like, I'll just mark that the binary needs a restart if the feature flag changes, and like eventually it'll restart, or we can give people like a policy for like, you know, if we've needed to restart for 10 minutes or something, then go ahead and just restart us.
Okay, so that helps a little bit with scope. There may be more questions there. I don't want to pretend that's
yeah. It's like basically I want to optimize for just dropping a replacement in for the existing command line client, right? Like previously you had to restart everything anyway if you wanted to change something. So like I'm not trying to optimize that necessarily. I mean, if you happen to have a feature that you can check statelessly and don't need a restart for, that's great. You just change the function you're calling from is enabled to like is enabled stateless or something, right?
Yeah. I have one more, and then I really will hand it over. I've got one more I'd like to ask now.
Yeah.
Back on your second point, you said you can't really turn off a feature, and then you said when you turn it off, I want to clean up what was there. Mm-hmm. I'm interested in whether there's like a further detail slide in here that breaks down what the different categories of feature are and what we actually want to have happen. So like one thing you could want to have happen is every pod that's using this feature gets deleted. Maybe that's a thing. You could also say, I want existing workloads to just coast on however they're configured. Deciding what to do there is not, I don't think it's one size fits all. And I'm interested in the breakdown that you have.
No. Yeah, the plan is like the feature author gets, like, I'm gonna call a function of some sort. It's gonna be like, I'm turning your feature off, go do what you need to do. And the cases I'm aware of, I don't have a slide for this, but the cases I'm aware of is like, it's like maybe it's a schema thing and it's easy to scan through and delete all instances of it in etcd wherever that happens to be. That's one possibility. Another possibility that I think Jordan brought up is like, imagine we have a new volume type, right? So people made these volumes and it's like super not practical and would be extremely unfriendly to go and delete people's volumes just because we're turning the feature off. In that case, I expect that instead of actually turning the feature off, it would go into the like, I'm turning off now transitional state and just stay there, which means you wouldn't be able to add new instances of this volume type. But the existing ones would still exist. And if the user manually went and deleted them, then it could complete its transition and go all the way into the off state. And then of course, there's also like the
so I guess part of what I'm saying here, and I'm amused that Jordan came up with the same example, but the part of what I'm looking at is it's not even clear to me that all clusters should behave the same way, right? Like I can definitely look and say, yeah, like, okay, I want to turn off this feature. Well, maybe one cluster says, you know what, nuke all of it. And another cluster admin says, no, don't nuke all of it.
Yeah, I think for cases like that, we would like not nuke things for people. And there would be like maybe we could put a condition on the feature or something is like, hey, we're stuck in the I'm trying to turn off now state. If you want to actually get it all turned off, then this is how you nuke all your objects. And if you don't want to do that, it's fine to just leave it like this until you turn the feature on again. That's one flow I could imagine. Yeah, I agree. We shouldn't be like making destructive decisions for all clusters. I wouldn't expect that. Like if there's going to be something destructive that needs to happen to actually get a feature all the way off, I would expect us to just give instructions and let the admin do that if they want to. It's not necessary.
I think it'd be very interesting to see what your actual cases come up with and whether anything that is stored could actually be removed without being considered destructive. I kind of doubt that they can.
Yeah, I think I don't have an example off the top of my head. Yeah.
Okay. That's just the first two that were like top of my list, and so and everyone's shy. No one else has hands. Well, maybe they'll ask once I stop here.
Let's see. Let's go back. All right, I'll just keep going for a little bit. I don't think we're going to get all the way through this deck.
Okay.
That's okay.
If there's no other question, then I got one more at the very beginning. Very first slide you popped up.
Yeah.
What categories of flags do we have? Right. Your very first slide talked about how cluster admins can't set flags, but I think there are some flags that cloud providers in particular really like being able to set in a way that users are not allowed to manage.
Yeah, that's actually the slide that's on the screen right now is my answer to that. What if I really like the command line turn it on and off? Like the dynamic API turning it on and off part of this is like an extremely minor part of the proposal. And whether we give end users or cluster admins or like who has the power to set that. So cluster admins can set it with RBAC, like who's allowed to modify these feature objects. And the way I'm currently proposing it is platform admins. If you want, like actually right now I've phrased it as an opt-in. If you want to allow a feature to be dynamic, you on the command line have to set it to a like is dynamic or set via API or something like, right? You have to opt it into that, right? Now I am proposing at least one change for platform admins, which is the gates move, like all the gates move to API server, the Kube API server, right? So they don't get set on kubelet anymore. They don't get set on controller manager or scheduler. All those binaries start reading the state from API server, right? So it's published by API server, and you can lock it so that you can only set them by the command line on API server if you want, or if it's that way by default, and you can open it up to people if you want. Does that answer your concern?
I would probably have to go through several of the flags. I suspect there's some where it's I want part of this settable via the API. Like, so I'm remembering Mo, and he wanted to be able to configure an OIDC authentication stack via a resource. And I remember significant resistance from
yeah, that doesn't sound like something that you should configure, like, especially if it takes other config from API server. Like there's no point in making it dynamic.
Well, so extending that concept out and saying, well, what if I want to have my authorizer configured via the API? That makes a lot of sense to do, right? Especially if you're a cluster admin and you say, like, I want my own webhook in there, right? Because I have my own rule and I want to specify it. And then at the same time, like, well, someone's going to say, I want to allow them to set it, except they can't remove the super important one that I have at the beginning of the chain. Right.
Yeah, I'm not proposing anything that complicated. I'm just like the I've got an API type later on in the stack, and like the only like most of it is in status, like whether the feature's on or off, or what state it's in, or like how stable it is, or what version is providing it. And the only thing in spec is like, can you turn it on and off? Right? I'm not proposing to add configuration to spec. I think if it requires configuration file to be passed to API server, this mechanism is not going to change that. Mo.
Yeah, I was just going to ask, since David was mentioning me, I don't, having lived through OpenShift 4, I am not optimistic about anything you've said so far. Not in the mean way, just like I expect like the fires to be very large, not small. But just to sort of think through what David said, it basically ends up meaning that the entire feature has to already be encapsulated by the Kubernetes REST API, and the only thing that you're trying to tweak is turning it on. Right? That's like a prereq to what you're sort of talking about. So authorizers don't get to be...
again, like the dynamic part of this is a really minor detail. And I don't expect it to work for all features. And so if your feature doesn't, if the configuration isn't in the API, then that's great. Just don't let people turn it on and off dynamically, right? If you didn't provide the config file for API server, then like you can't turn it on anyway. That's good. The initialization is going to fail.
Right. I guess I don't exactly know how I would use such a system. Right. Like, so
I mean,
like,
you don't have you don't have to use such a system to turn a feature on and off. Like that's not necessarily something you use.
So let's take, for example, the authn example that David likes to pick on me for, right? Like EKS lets you set all of authn through a cloud API, right? So for them, they might be like, cool, I'd like you to have dynamic auth through the Kubernetes API because you can already do it through the EKS API. So it's just like more easy, right? So like it's sort of arbitrary, and I'm trying to figure like how I. So
I think a more typical feature inside Kubernetes is like, adding a volume type, or it's like things that are early in their life cycle, like was the max unavailable field that we added to staple sets, right? Like that's the sort of thing that I think is more typical. I think authn is like authn webhook is extremely unique, and there's not that many things like that in Kubernetes compared to like the other kinds of features. Or like another feature is like the aggregated discovery stuff, right? That's a feature flag. That makes a lot more sense to let users turn on and off than their authn stack. Like even I'm a little scared about letting them mess with the authn stack.
So like both EKS and GKE have supported feature sets that are effectively dynamic authn stacks on your Kubernetes environments, right? So like,
yeah, but I don't think this mechanism is good for that, because this mechanism is not aiming to let people pass the necessary configuration for things that need to be configured.
Yes, I mean, so I guess that's sort of the takeaway I'm having, right? Is either the feature's already configurable through the API, just it can't be turned on or off, and that's all you're changing. And thus things like CAMS never come up, because how would you?
So yeah, again, like the dynamic turning it on and off is a small part of it's just like, oh, I'm making an API object to announce the feature's existence in its current state, and like that happens to mean that it's easy to let people turn it on and off through the API. But that's like a very, it's just, well, I'm there. While I'm taking your engine out, I might as well change your oil, right? Like it's.
Yeah, I mean, so like, I don't know if I would agree with the statement is minor, mostly because like there's tons of wiring in the API server that statically checks, hey, is this feature enabled? Then like wire it up like this, otherwise do a completely different thing, and it never reevaluates those if statements. There's no
Yes,
need.
that's the difference between the stateless and the stateful checks that I was mentioning. I'm not sure if we can check everything on startup, and if not, we may need to cache things locally so that you can, the things that you need to check before you have gotten far enough to have API access to the cluster. Yeah. Anyway, I think we're over time. Thanks for the feedback, everyone. And I don't know, I'll probably like start an issue or a cup or something to capture this if you want to give more feedback, or you can just yell at me on Slack.
Okay, I think you should create an issue to continue the discussion, and then we are going to move the rest of the topics for next meeting. Remember to try to add them in advance the day before. Otherwise, it's just we calculate the time for the existing items. Thank you, everybody, for attending. I will upload the recording later today. Have a good rest of your Wednesday and week. Take care.